Please welcome Eric Hesseldahl.
Thanks. A bit about me. I'm a technology journalist for 20 years, and about 5 years ago, I got to write that story, which you see on the screen for All Things D. I later worked for Recode, and you can see from the headline that I kind of understood. I don't know anything about networking engineering. You're all really smart and really great at that, but I know the potential for disruption when I see it. And when I first got to meet Nicira, which, as you all know, went to VMware and became kind of the foundation of NSX, I saw the potential for a really big thing happening in networking. And so a couple years along the way, I got to talking with an analyst friend of mine as I continued to cover this kind of enthusiastically, software-defined networking. I asked an analyst friend what he thought of it, and he said, "Oh, you don't know my joke about software-defined networking?" And I said, "No." And he says, "Oh, it means still does nothing." And that was maybe 2014 or something like that. So my feelings were kind of hurt because I was kind of enthusiastic about it, but I said, okay, times change. Well, 2017 is here, times have changed, and so I'm kind of excited about this next group of speakers because we're going to talk about some people who are actually using this technology, using everything about this that got me so excited 5 years ago. So I'm going to start, I'm going to get off the stage. We'll do some Q&A after, but I'm going to introduce Manish Mehta from Netflix.
Thanks. Hello, everyone. Just show of hands, how many people have heard of Netflix? Sure. Okay. How many people you think Netflix hires to configure their routers? Zero. Almost, yes, almost. How many routers do you think we have? Zero. Now, we are 100% AWS shop. We have 100 million subscribers. We are everywhere except for China. Don't ask me why, but in the world. And expanding, obviously. And the reason we don't have any routers or necessarily a dedicated person configuring routers and putting routing rules is because we decided that that's not our core competency. The people we hire, we want them to concentrate either on buying content, or generating content, make great shows, or on the engineering side, write their applications that make Netflix UI look better, Netflix subscription flow go smoother, and stuff like that. So if I'm a UI person trying to deploy my UI application, should I really be thinking too much about how networking rules change the way I deploy something when the demand or the number of subscribers are watching that shoots up in the evening time? I need to scale up my application and add two more instances to it from AWS. What does it take? What does it mean in terms of networking? So what you will see in this talk is a little bit of talk that is above networking, where we tend to not worry about networking and how we do that. And then we'll also talk about my main purpose, which is security part of it, because I come from that background, and how security basically impacts all of this, and we basically go about one level above networking. So just some housekeeping stuff. So whatever I talk about right now is what we have done, what we have tried to future-proof ourselves for, but doesn't necessarily mean that Netflix has some business plan for the future or any of that. So don't read too much into where Netflix as a company is going into this presentation, at least from business side of it. Okay, so I think what Pierre mentioned in this morning, I think it captured it very well. People don't think about networks anymore. People think about infrastructure. So I don't know how many of, maybe take a guess, but we run microservices, thousands of them in the back end of Netflix. Even before you hit play and the movie starts playing, your your control plane, like our backend control plane, basically makes sure that you are the right person to stream this particular movie at this particular resolution. You're not streaming more than couple of streams that you're allowed, whatnot. All that happens in the backend. What rows to show you, what you may like, what shows you may like, all those things happen in the backend, controlled by thousands of microservices. All these thousands of microservices scale up and down, sometimes manually, sometimes just based on some predictive analysis. So sometimes people are not even involved. I'm sleeping and my application is actually scaling up and down in the middle of the night. So having said that, security in such kind of environment becomes very interesting. But at the same time, if you're not a security person, what does cloud security, what does network security kind of mean to you? So just for fun, I actually made a Google search and obviously filtered it by images I could use it commercially free. And then these were the 3 top images I could find for a search query of cloud security, I think, or network security. As you can see, there's basically very little overlap. And this is exactly why people like you don't like to talk to security people like me, because we don't make sense. If you ask 3 different security people, tell me something about security, the first person can go on and on about all the keywords in the first one, and the third one, the second one and the third one, and then you are completely confused. And it's not necessarily because they don't necessarily know their field inside security, but it's vast, and then in order to make sense, you have to go get deeper into the basics and fundamentals of security. And once you start asking those questions, very fundamental questions in security, and then solve it at that point, then things fall in place. And then all these things start making sense. So look at this presentation mostly from engineering side of things. I don't have any math to show you at this point, or any validation or verification, which absolutely fascinated me in the previous one. But in this case, I look at this whole presentation from engineering side of view. So let's see. And I can get a clicker that works. Right. All right. So as security people, what exactly do we want? So most people who are developers, they come and they see security people as no-sayers. Every time we come and ask you something and you say no. Right? But if we ask ourselves as security people what we want at most fundamental level, that's all we want. What we want to say is, give me a simple way to define and enforce rules that read something like this. Identity I can or cannot perform operation O on resource R. So what is a resource? Resource can be anything. Resource can be a file. Resource can be an encryption key. Resource can be a database column, database row. Operation can be read, write, execute, encrypt, decrypt, whatever. So because I have 20 minutes, I'm not going to go into all the details of all the aspects of those rules. So O and R is up to the business. Depends on a lot on what kind of business you're running, what kind of resources you're hosting. But I is what I'm going to focus on. So identity, until now, we have done fairly good job as industry and as security people to think about identity as users. So I know that user A is a vice president of something, and he or she gets access into this system, complete access and stuff like that. Some other person is an HR person. That HR person cannot leave any systems outside of HR. So at user level, I think we have done fairly good job. But that's old story now, because most of the things that we talk about today, they're not necessarily user originated, or user is not even taking action. Like 2 minutes back, I mentioned something about I'm sleeping at night and my system decides that there is more traffic coming in, more people watching because it's Christmas Eve, and your system needs to scale up. That scale up happened automatically. That means there was no user interaction needed there. So who took the decision? And whoever took that decision had to be authorized to do that action. So at the end of the day, whatever happened at this point, user was not involved. So that system was basically some running code looking for some level of traffic and triggering a scaling event, which basically ended up adding 2 more instances to my application cluster. So we'll mostly try to focus on identity that is not users, identities that are code. So before we get there, some background, because identities are very closely tied with running code and how they run. So in good old days, it was pretty straightforward. You had one physical machine, you had one program, somebody came and started the program, it finished to its execution, and then spit out the output. Great, no problem. Security boundary is physical machine. That program assumes that security boundary, and things are great. Then we move to the next step, where you had same physical machine, now you have multiple programs talking to each other. P1 making a call into P2, P2 didn't care much, or maybe relied on the operating system to make sure that, okay, P1 is allowed to make that call. So still okay, because security boundary was still considered physical machine. Now I think things started getting more interesting when we started putting stuff on network, because now you left your physical boundary, which was the machine, and then you started putting stuff on network. Once you did that, what was the identity of P1 talking to P3, let's say? Obviously, there is a typo, P3 and P4. OK, so let's say P1 on machine 1 talking to P3 on machine 2. At this point, we basically now started asking questions about identity, because we want to make sure that when P3 receives a call, it could be from anyone, from M1, M2, M3, wherever. So the identity at that point became IP addresses and port numbers. So we started putting all the ACLs on firewall, at firewall level, so all IP and port level. Now, people wanted to make sure, for multiple reasons, including disaster recovery and whatnot, to basically put their networks in different places. So now you have more than one location, and then you have some sort of end-to-end VPN connection that you ended up connecting all your data centers together. And they started, at the same time, some smart people were thinking about how to do elasticity within a given physical machine. So they created concept of virtual machines, which basically within a physical machine, now you have on the network something that looks like multiple machines. Then you add that complexity into the network, and now you have VMs everywhere, multiple locations, right? Now you're probably thinking, what happened to that identity of code? Now think about it this way now. VM1 on machine 1 in left side of the data center is now talking to VM4 on right side of the data center on machine 2. What is the identity? Where do you put the ACLs? Right? Let's make it slightly more complicated before we answer this question. So not only that I had multiple data centers, now I'm actually talking about multiple cloud providers. So I don't even have control over some of the, and I mean, you can imagine I color-coded those clouds so that you can get a hint. But, and then we wanted world to be even more complex. So we basically went from VMs to containers. And then purist will come back and tell me that why is your container with multiple processes? But that's fine. People do containers also in their own ways. OK, so this is where we are today. If you want to think about this way, you have a data center, then you have 2 cloud providers, and then you have containers running everywhere. So now let's get back to the identity question. And then the way I would start is back to that jargon, the word cloud. There was one word cloud with one word end-to-end embedded somewhere there. What does it even mean from security perspective? What is end-to-end? Right? We talk about end-to-end where mostly marketing people use in their glossies and stuff like that, right? Sounds pretty cool. But from my perspective, as a security person, end-to-end is if I own a resource, I want to make sure that whoever gets to access this resource, perform any operation on that resource, I have the most granular identity of that piece of code or user as granular as possible. So in my case, if I have a container running in my data center on a physical machine M1 in virtual machine V1, that is talking to a server that is in cloud provider 1, region 1, account 3, machine 2, VM 4, container 4. Okay. And first of all, that looks ugly because the whole namespacing is so different. It doesn't look like IP address or any of that. If you have deployed anything in AWS, you are probably familiar with something like that, which is slightly better than what it was before. But it's still not very useful. What does I123456 mean anyway? Right? So when client wants to talk to the server, that's the identity he's getting from the cloud provider. At the same time, if I'm running in my data center, how do I even understand what AWS means by I12345? Right? So first thing first, when you have your workloads separated in your data center, AWS, whatever other cloud providers, they have their own naming scheme. But that's not. You're not slave to their naming scheme. You're supposed to take control of your own naming scheme and then try to see if you can map your naming scheme to their naming scheme. So first thing you want to do is get rid of that. The reason you want to get rid of that is because the left side, DC M1 V1 C1, can change its name to CP2 Z1 P2 whatever. What happened here is the workload that used to run in your data center, the team that was responsible for that chose to start running their workload in cloud provider 2. So as a server that you were running in cloud provider 1, you have no control. The way Netflix works, at least in this case, is I don't get to choose which micro services run in what area. I have no control. Those teams are actually making their progress their own way. So at the end of the day, if they were deploying in the data center and now they're deploying in some other cloud provider, the traffic is still coming back to me and I have to identify and put all the authorization rules on their call. I don't get to choose where they run it. So first thing first we need to do is basically unify these names. Regardless of where you are running your code, you need to unify and come back with one kind of human readable, understandable naming scheme, which is something like this. Instead of DC M1 V1, what if I told you your code is now identified something like my company, my business unit, my project, my application, and my container? It's much easier to explain to someone what this means. At the same time, if you change your deployment, you went somewhere else, you change your cloud provider, the receiving side doesn't have to even know that this happened. It will still identify you as that name. And then the most important part from security perspective is in order to map your current running code to that name, you need support from your cloud provider so that you can securely bootstrap with their local identity, whatever local identity your cloud provider or data center gives you, and then map it to this unified identity. So here's where I'm going to plug my one of our very, very successful open source projects that Netflix has. It's called Spinnaker, www.spinnaker.io. What we use it for today is we use one tool that allows us to deploy our code into AWS. There we have our own container management system, which is called Titus. And then it is basically also very pluggable and expandable. So if you want to start using that for your data centers, you can do it. It's not free. You still have to do some engineering work. But basically now you have one tool that allows you to manage all your workloads across and then makes migrations very easy. All right, and then the second part, I think this is where the security people will have a good kick. It's not enough to tell that a given identity in AWS should now have identity my application, my container. You need to somehow cryptographically bind these two things and bring them together and be able to prove it to someone that yes, this is the actual code that I'm giving my credentials to. So how do you do that? AWS, by the way, gives you something called signed identity document. So if you have any workload running in AWS right now, you can easily go to metadata service and look for a PKCS7 signed CMS block, which basically tells you something about their local identity cryptographically, saying, hey, I'm AWS. I guarantee that this piece of running VM is a particular identity. And then in case of Google, I just read something about the new Titan chip, which basically allows you to securely bootstrap. So ultimately, that becomes your root of trust. In case of data centers, most of your machines may have TPM, and then if you provision them properly, then maybe that becomes your bootstrapping mechanism. So ultimately, what we are trying to do is, regardless of where you are running, data center, AWS, Google, some other cloud provider, you can take their local identities and get this kind of bootstrapping material from them and tie it to the uniform identity I talked about. And once you have the uniform identity, you can start writing your authorization and authentication rules. And then you don't even have to worry about how at networking level these things are connected. You can keep networking at a level that you don't have to worry about. Let network people worry about it. In my case, at network level, most services can reach each other, no problem. But traffic will get rejected if they don't have the right uniform identity certificates. In my case, I use mutual TLS. So they have to have that certificate. So what we achieved here is we went from that weird looking mapping between a client and a server naming scheme to uniform naming scheme. And then if I go back to my identity then what I ended up doing here is now I have some naming scheme that allows me to write very nice human readable authorization rules. And once they're nicely readable, the chances of error are less. It is easier for logging and forensics. As a security person, I'm always interested in forensics. And then easier for metrics and alerting. So one takeaway I would say, if you're a cloud provider or data center administrator, please make it easy for your customers to securely verify your local identity. And if you're a user, demand that from your cloud provider or data center provider. And then you can build your uniform identities. So I think I will take questions after. Thank you.